Welcome to the live interactive session for the course Water, Society and Sustainability. I am Aman Srivastav, the teaching assistant for this course. The primary intention to have this live interactive session is to solve some problems on the course Water, Society and Sustainability. So along with all the theories which are contained therein, we are also looking forward to quantify those theories and try to solve some practical problems to realize the further importance of such course in the practical applications. So the objective for the week 1 is to estimate annual water budget of a typical Indian village based on the learning from week 1 lectures and propose recommendations for management. So I'm pretty sure that all the enrolled candidates for this course have already seen week 1 lectures and must have also attempted to solve the assignment. Now, based on the understanding that we have developed by going through the lectures of week 1, let us try to formulate a problem for a typical Indian village and estimate the annual water budget. When I say water budget, it means that we wanted to account how much is the water available, how much is the water available for supply, how much is the demand, and how we are going to manage the stored water for supplying and fulfilling the demand. Altogether, we are also looking forward to propose recommendations based on the learnings or the calculations that we will be doing for estimating the annual water budget. And the conditions to consider while solving this problem is these. These conditions are generated from the learnings from week 1. For example, climate change as a planetary boundary framework that you have already studied. Water as a resource to be managed, controlled and hence quantified. Socio-hydrology, political ecology and hydrosociology of water will be considered. Transdisciplinary approach rather than limited to disciplinary approach will be considered while solving the problem. Advancing the science of hydrology for the benefit of society and integrated water resource management framework. So when we will be solving the problem having this objective, we will try to retain these understandings or these learnings that we have developed from week 1 lectures. And enough discussion has been made by Professor Jenia Mukherjee ma'am for each of these points through her week 1 lectures. So I request all the enrolled candidates to revisit the lectures which were taught during the week 1 of the course Water, Society and Sustainability, which will allow us to better understand the objective and the problem associated therein. Okay, so now let's frame the problem. You are a technocrat cum policy maker investigating a village located in the semi-arid region of East Maharashtra. You were told that the village is witnessing water scarcity problems during non-monsoonal season. So yeah, it is clarified here that you are not only policymaker, but you are also a technocrat who is also responsible to look into the technical aspects of water context. And we are investigating a village located in East Maharashtra. So when I say East Maharashtra, it is the locations of Vidarbha and Marathwada, which are frequently undergoing or witnessing the impacts of floods and droughts due to climate change. And yeah, so the problem that the villagers were facing is the water scarcity, and that is occurring mostly during non-monsoonal seasons. It is those seasons where rainfall is not predominant. So usually in Maharashtra or in general India, we have the southwest monsoon during June, July, August, September. And we in India, certain parts of South India such as Tamil Nadu, Andhra Pradesh, they also receive their major portion of rainfall during northeast monsoon, particularly in the month of October, November, December. However, our current problem statement deals with southwest monsoon, and other than southwest monsoon, that is June, July, August, September, remaining months are non-monsoonal seasons. So the village is undergoing of facing water scarcity problems during the non-monsoonal seasons or non-rainfall seasons. You are objected to identify the preliminary reasons behind water scarcity if exist, considering the annual water budget of the village. Okay, so this is again reclarified here that we are looking forward to estimating the annual water budget, and we wanted to find out what is the reason behind the water scarcity through the approach of estimating the water budget. And to find that, some information regarding the village has been given to us. So this data, we can assume, has been given to us by former researchers, and now you are a technocrat come policymaker who is reinvestigating the findings from the previous researchers. There are four land uses in the village, respectively forest, agriculture, built-up, and lake. The corresponding area cover of each of these land uses are mentioned here. The rainfall is very high, which is 2650 mm in the study area. So we are assuming that this is the study area is small enough wherein the rainfall is uniformly distributed for all the study land uses. The storage that is possible from this rainfall for each of the land uses are also provided. For example, of the total rainfall, 8% is stored as a surface water resource in the forest. Similarly, for agriculture, 11%. In built up, it is very less, it's 4%, and for lake, it is maximum 53%. So, since lake is a surface water storage structure having a depression, that's why able to store more water than forest or agricultural land use. However, in the case of built up, it's a concrete land. Usually, the built ups is a land cover where it is concretized, as a result of which storage opportunities are very limited. The former researchers also provided you the information regarding how much was the losses in the water. They found that the amount of water which is lost is 24% in case of forest, 24% in case of agriculture, 15% in case of built up and lake. Now let's try to further understand how these phenomena or the magnitudes are actually be used while solving the problem. So this is the typical illustration of the village. This is the forested area at a elevation greater than the elevation of the agriculture. So whenever there is a rain occurring, we can simply identify that the water must be flowing through the forested regions to agriculture and thereby to lake, and the surplus water from the lake must be going somewhere downstream villages. We have built up area, we have agricultural land use, we have lake, and we have forest. So from the knowledge of engineering hydrology, we know that the rainfall is the total amount of rain which is received in this region, and if we want to find out how much is the water which run off from this catchment or from this village, we need to use this equation: rainfall minus storage minus losses is equal to runoff. However, when this live interactive session was taken, the enrolled candidates raised a very intelligent question, which is what are these losses and why we are assuming this as losses. So here these losses are nothing but the water which is evaporated back into the atmosphere, or which are evapotranspirated back into the atmosphere, and the water which underwent for groundwater infiltration. So evaporation, we all know it's a surface phenomena where the water in the lake is evaporating back into the atmosphere. Evapotranspiration is the phenomena which is predominantly occurring in the vegetative areas, where not only evaporation but the transpiration from the vegetation forest is also occurring simultaneously. And groundwater infiltration is the process where the portion of the rainfall is infiltrating down the ground through soil. Now the question is, are there really losses? So if we go typically from the engineering hydrology point of view, yes, they are considered as losses because they are not helping us to increase the storage, or they are not actually allowing us to conserve water within the catchment or within the villages. Hence, from the engineering hydrology point of view, it is considered losses. However, if we look into socio-hydrology or hydrosociology point of view, these are not the losses, because all these phenomena are essential for further continuation of hydrological cycle. Also, for example, groundwater infiltration help us to recharge the groundwater sources. So indeed, we cannot call all these processes as losses as what it is critically considered in engineering hydrology courses. Now let's try to identify the annual water budget, and I have taken one sample for agricultural land use. So before solving this problem, we should need to brush up our past concepts. For example, volume is nothing but it's the product of depth of rainfall into area of the land use, which provide us volume. 1000 mm is 1 meter, and 1 hectare, which is the area of each of the land use in the unit of hectare, is expressed as 10,000 square meter. So using these units and conversions, we can solve or we can find out the water budget, annual water budget for agricultural land use. So we already know that the area of the agriculture is 35 hectare and the amount of rainfall which is received on agricultural land use is 2650 mm. The rainfall volume thus will be 35 into 10,000. We have converted the hectare into meter square, and we have converted the rainfall magnitude in meter, and we have converted the final output in 1000 cubic meters. So the total amount of rainfall which is received for agricultural land use is 927.5 thousand cubic meters, of which 11% is the storage, which comes out as 104.3 TCM, and the losses were 24%, which comes out as 220.3 TCM. So substituting these values in our final equation for finding out the surface runoff, the amount of water which run away from the agricultural land use is P minus S minus L, which is 927.5 minus 104.3 minus 220.3, which yield us 602.9 thousand cubic meters of water. So we can simply see here that the amount of rainfall which is received in agricultural land use is 927.5 TCM, of which 602.9 TCM is the surface runoff. So one judgment that we can take here is that the amount of water which is flowing away from the agricultural land use is very high. And similarly, we can perform these estimations for other land uses. So this is the homework for you, that you have to use this data to find out what is the surface runoff for each of the land uses. And verify that the summary which is provided here is matching with these calculations that you have done. So here is the summary of all the land uses, and we have identified the surface runoff corresponding to each land uses. So for forest, we see here that the rainfall is 795 TCM, of which 542.6 is converting as surface runoff. It is that portion of rainfall which became surface runoff. Similarly, for built-up it was 534.1 TCM of 662.5, and for lake it is 86.1 from 265 TCM. So if we want to have some observations from this final annual budget summary, we could see here that the surface runoff is very high, respectively 68% for forest, 65% for agriculture, 81% for built-up, and 33% for lake. So one generalization that we can make here is that this village is undergoing rapid surface runoff. So the opportunity for harvesting this surface runoff is limited. That's why the village could be witnessing water scarcity problem. Therefore, one of the solutions that we can generate based on the learnings of surface runoff, we can say that if we propose solutions that can allow us to harvest this high quantity of surface runoff, then might the water scarcity problem could be solved for the non-monsoonal seasons. Because if we are able to capture or harvest this excessive surface runoff, this can allow us to have certain more storage to fulfill the water requirements during non-monsoonal seasons. For example, if we if we propose rainwater harvesting scheme in the built up areas where the losses are as high as or the surface runoff is as high as 81%, then might we will increase the storage or we can reduce the water supply demand because some portion of the water demand can be fulfilled from rainwater harvesting scheme, which can allow us to reduce the surface runoff from 81% to certain percent. Likewise, we can also construct check dams or farm ponds. What are check dams? Check dams are the surface water storage structures which are constructed by finding out these streams and developing a structure or earthen embankment across these streams such that we can harvest the excessive surface runoff at the upstream of the earthen embankment or the structure which is constructed across the streams. Similarly, we can also look forward for constructing farm ponds within the agriculture land use, and these constructions can allow us, or these propositions can allow us to increase the surface runoff harvesting. Likewise, another solution could be the desiltation of the lake. Maybe because of the high surface runoff, the deposition of this silt or because of the high surface runoff, there could be a chances that the study regions must be undergoing soil erosion, and most of the the silt which are generated as a result of surface runoff may be carried by the flowing stream, high surface flow streams, which is being desilted, which is being deposited in the lake. As a result of which, as a result of the siltation of the lake, the the volume storage must have been reduced. So this is a kind of assumption that we are taking based on the learnings from this table, that if we look forward for finding the scope of desilting the lake, where we will dig out or we will take out the silt which are accumulated in the lake, then the storage capacity of the lake can be increased, which can allow us to harvest further surface runoff which are generated from different land uses, because we all are aware that the lake was located at the most downstream, while the agricultural land, the forest land, and the built up were all located upstream of the lake. So there are high chances that the silt or the soil being eroded from the surface runoff could be deposited in the lake. However, the solutions that we have identified based on the annual water budget was not sufficient enough to answer so many questions, because how about season-wise analysis where water budget can be estimated for southwest monsoon, post-monsoon, winter and summer? How about also take into account the agricultural water draft, domestic water demand, livestock water requirements and institutional water needs? And how about designing decentralized water management system and governance based on cascading framework of surface water storage structures? So this entire problem merely focused on identifying what is the flow of water in the village context, in the form of rainfall, in the form of storage, and in the form of losses from the engineering hydrology point of view. And on the basis of all these values, we identified the surface runoff which is occurring from each of the land uses. And we landed up with this idea that since the surface runoff is very high, we can look forward to harvesting surface runoff to increase the water conservation within the village context to solve the water scarcity problem during non-monsoonal seasons. However, when we say non-monsoonal seasons, we haven't accounted for seasonal water budgeting, because the current problem statement was merely focusing on annual water budget. But our focus should also be on seasonal water budgeting, which we will be looking in week 2 lecture. Furthermore, it is not only about how much is the water available for supply, but we are also interested to find out how much is the demand, because the difference between the supply and demand can give us an opportunity how much is the water available to meet the demand, whether the water is surplus enough to meet the demand or whether the water is deficit, the storage is deficit, and we are looking forward for further storage of the water such that we can meet the high water demand from the village, but we are unaware currently from the current problem statement. So which instigate us that we have to deep further into this problem and find out how much is the agricultural water demand, how much is the domestic water demand, and what are the livestock and institutional water needs. We are all aware that there are so many institutions within the villages such as the Sarpanch or Panchayati Raj institutions, likewise Anganwadi, Jila Parishad School, etc. Since it's a village contest, definitely there are scopes of water demand from livestock such as having cows, bulls, or poultry farming, etc. And that's why if we are having the information about how much is the water available, how much is the water available for supply, and how much is the demand, then we can come up with some propositions regarding decentralized water management system that we can look in the last lecture for this live interactive session. With this, we come to the end of the live interactive session for the week 1, and I sincerely request all the enrolled candidates that they should go ahead and solve the remaining portions of estimating surface runoff from the present lecture, and stay tuned for solving further parts of this problem in week 2, week 3 and week 4. Thank you.